Hello children, in this video we'll continue with the CBSe Maths question paper, board paper 2022, section B. Now question number 7 to 10 carries 3 marks each. Let us go into the question. Find the particular solution of the differential equation x dy by dx plus x cos squared y by x is equal to y, given that when x is equal to 1 and y is equal to pi by 4. This is going to be easy. Now this cannot be solved by the variable separable method because it is a homogeneous equation. So x dy by dx plus x cos squared y by x is equal to y. Now the first step is, let us divide throughout by x. On dividing throughout by x, we get dy by dx plus cos squared y by x is equal to y by x. Now let us put y is equal to vx. On differentiating on both sides, we get it to be dy by dx is equal to vx is now going to be, we can differentiate that using the product rule, uv dash plus bu dash. If I take v as u and x as v, I will get uv dash. V into, when I differentiate x, I'll get it to be 1 plus, on differentiating v, that is, I will get it as dv by dx. So x into dv by dx, or in other words, dy by dx is equal to v plus x into dv by dx. Now in the place of, and so therefore y by x will be equal to v. Y by x will be equal to v. So in the place of y by x, I am going to put v, and in the place of dy by dx, I am going to put it as v plus x dv by dx. Right? So that is now going to give you v plus x dv by dx plus cos squared v is equal to v. Now this v and these v will get cancelled. Now it's going to be pretty easy. Now we can solve this by variable separable method. I'll bring all the v to one side and x to one side. So it will now become dv by cos squared v is equal to, or first let me go with this step and then let me go to the next step. That is, I will take x into dv by dx. I'll take this cos squared v to the right hand side. So I'll get it as minus cos squared v. Or now separating the variables, I'll get it to be dv by cos squared v is equal to dx by x. Now I can rewrite this as integration of secant squared v, because we know 1 by cos squared is nothing but secant squared. So secant squared v into dv is equal to integration of dx by x. Now differentiating on both sides, I will get this to be tan v is equal to, you have a minus symbol here, is equal to minus of log x plus c. Or now you can substitute back for v as y by x. So that will give you tan of y by x is equal to minus log x plus c. Now to obtain the value of c, we have to substitute in the place of x as 1 and y as pi by 4. So that will give me tan of pi by 4 by 1 is now going to be tan pi by 4, which is equal to minus log 1 plus c. But we know log 1 is nothing but 0. So, and tan pi by 4 is 1. So this implies c is equal to 1. So therefore, the equation, the required solution is now going to be tan of y by x. I'll bring this log x to this side. So plus log x is equal to 1 is the required solution. Second question, that is the 12th question, we have a choice. So if A vector, B vector, C vector and D vector are 4 non-zero vectors such that A vector cross B vector is equal to C vector cross D vector and A vector cross C vector is equal to 4B vector cross D vector. Then show that A vector minus 2D vector is parallel to 2B vector minus C vector, where A vector is not equal to 2D and C not equal to 2B. So, in order to prove that A vector minus 2D vector is parallel to 2B vector minus C vector, it is enough that we can show that A vector, the cross product of A vector minus 2D vector and 2B vector minus C vector should be equal to 0. That is, I can now write this as A vector minus 2D vector cross 2B vector minus C vector. Now, when I expand this, I will get this as A cross 2B. A cross 2B minus A cross C minus 2D cross 2B. Minus of minus will become plus 2D cross C. So, A vector cross 2B vector minus A vector cross C vector minus 2D minus 2B vector plus 2D vector cross 2C vector. Now, look into the condition. What are the conditions given? It is given that A vector cross B vector is equal to C vector cross D vector. So, A vector cross B vector. So, this and this can be cancelled. Yeah. So, you can see that A vector cross B is equal to C cross D. A vector cross B and C cross D. So, this is now going to be, or I can rewrite this as, okay, let me rewrite this. A cross 2B minus A cross C, and this I'll rewrite it as plus 2B cross 2D, because you know D cross B is minus of B cross D, right? So I'm rewriting this. And same way, this D cross C I can rewrite it as minus of C vector cross 2D vector. So this and this, A cross B is C cross D. So this and this will get cancelled. Similarly, he has also said that A cross C is 4B cross D. So 4B cross D. So this and this is now going to get cancelled. So therefore, this is going to be 0. Since the cross product is 0, the two vectors are parallel to each other. That is, A vector minus 2D vector is parallel to 2B minus 2C. Now look into the choice question B. The two adjacent sides of a parallelogram are represented by 2i vector minus 4j vector minus 5k vector and 2i vector plus 2j vector plus 3k vector. Find the unit vectors parallel to its diagonals. Using the diagonal vectors, find the area of the parallelogram also. Alright, so this is going to be easy question. Now, first of all, let us draw the parallelogram. So, this is now going to be the parallelogram. Let me mark it as PQRS. So, first let us find out the diagonal PR. So, PQ plus QR will give you PR. So, PQ vector plus QR vector is equal to PR vector. Now, given PQ vector is, you can see that PQ vector can be taken as 2i minus 4j minus 5k. So, PQ vector is 2i vector minus 4j vector minus 5k vector, and QR vector is 2i plus 2j plus 3k. So, 2i vector plus 2j vector plus 3k vector. So, when I add I and I will get 4i vector minus 4j plus 2j will give you minus 2j. Minus 5k plus 3k will give you minus 2k. Minus 2k. So, he is asking you to find out the unit vector parallel to its diagonals. So the unit vector which is parallel to its diagonals is now going to be, so 4i, so this is now going to be PR vector. Okay, so the unit vector which is going to be parallel to this is now going to give you 4i vector minus 2j vector minus 2k vector divided by root over 4 squared plus 2 squared plus 2 squared, which is nothing but 4i vector minus 2j vector minus 2k vector divided by 16 plus 4 is root 24, or I can write it as 2 root 6. Now I can take 2 as a common factor and cancel out the 2. So finally I'll get this as 1 by root 6 into 2i minus j minus k vector. So 1 by root 6 times 2i minus j minus k vector. So this is PR vector. Next, let us go to the other diagonal, that is QS vector. QS vector is now going to be, so I'll write it here. So to QS vector is now going to be, QS vector is equal to, it is nothing but SR vector minus QR vector. So, which is nothing but, so we have to subtract this. That is, SR vector is nothing but parallel to PQ. So I can rewrite this as, so in the place of SR I can put it as 2i vector minus 4j vector minus 5k vector minus, this is now going to be the same, that is 2i, let me put it within brackets, be careful of the symbols children, 2i plus 2j plus 3k. So when I subtract both, 2i and 2i will get cancelled, minus 4j minus 2j will give you minus 6j, and minus 5k and minus 3k will give you minus 8k, or I can take the negative symbol out and write it as 6j plus 8k. I can rewrite this like this. Or negative is now going to be a scalar quantity. We need only the vector quantity. So we can write it as QS vector is equal to 6j plus 8k. So we have found out the diagonals. So diagonal PR is equal to, we found out to be 1 by root. So PR vector is equal to, so it was PR vector, right? PR vector we found out to be 1 by root 6 times, sorry, that was the unit vector, I'm sorry. So we have to find out the unit vector for QS also. So that will now give you, unit vector for QS is now going to give you 6j plus 8k over root of 6 squared plus 8 squared, which is nothing but 6j plus 8k divided by 36 plus 64 is root 100. Root 100 is nothing but 10. Now I can take the 2 as the common factor and write it as 1 by 5 over 3j plus 4k. So these are the respective unit vectors. Next is asking us to find out the area using the diagonal vectors. So we know we have already found out PR vector and QR vector. You don't take the unit vectors, we have to take the diagonal vectors. That is, PR vector is equal to, PR vector we found out to be 4i minus 2j minus 2k, and QS vector is equal to 6i plus 8k. Now area of a parallelogram using the diagonals is now nothing but half into D1, area is equal to half D1 cross D2. Okay, modulus of half D1 cross D2. So that will be equal to A vector, or area is now going to be half into, so using the method of determinants, you can now take it as I, J, K, and this is now going to give you 4 minus 2 minus 2. 4 minus 2 minus 2 and 6j, right? 6j. I made a mistake. 6j. This is 6j. 6j plus 8k. So 0, 6, 8. Now on expanding, we get this to be half into I into minus 16, 8 2s are 16, 6 2s are 12, minus 12, minus of minus 12 is going to give you plus 12. And minus j vector into 4 2s are 8, 4 8s are 32 minus 0 plus k vector into 6 4s are 24 minus 0. So that is now going to give you half into minus 4i minus 32j plus 24k, or dividing throughout by 2, that will give you minus 2i minus 16j plus 12k. So the area is now going to be the magnitude of this. So therefore area is now going to be root over 2 2s are 4 plus 16 squared is 256 plus 12 squared is 144. So that is now going to give you 144 plus 256 plus 4 is now going to give you root over 404 square units. Moving on to the next question. This is also a choice question. Let us go to A first. Find integration of x cubed plus x by x power 4 minus 9 dx. Integration of x cubed plus x over x power 4 minus 9 dx. Now, it will be easy if I separate these two and write it as integration of x cubed by x power 4 minus 9 dx plus integration of x by x power 4 minus 9 dx. Now what I will do is, I can solve this by the method of substitution. Let me put x power 4 is equal to t. I will get it as 4x cubed dx is equal to dt, or x cubed dx will be equal to dt by 4. So this will now reduce to integration of dt by 4 divided by t squared, because x power t I can write, okay, in fact I can take x power 4 minus 9 itself as t. So that will now become t. Or when I'll differentiate this separately, I'll take this as I1. Okay, I1 is now going to be equal to this. I'll take 1 by 4 outside because it's a constant. So that will now become dt by t, which is nothing but 1 by 4 log t, log mod of t. Or that is now going to be equal to 1 by 4. Let us substitute back for t, that will give you x power 4 minus 9. Now going to the second differential, that is, let me take that as I2. I2 is equal to integration of x by x power 4 minus 9 dx. Now let me take u to be equal to x squared. In that case, I'll get du is equal to 2x dx, or x dx is equal to du by 2. Now in the place of x dx, I can now put it as du by 2. So integration of du by 2 divided by, this will now become u squared minus 9. So this is now going to be equal to I2. On integrating, I will get this. Now you know this is of the form. I'll take the half outside. Half integration of du by u squared minus 9. This is of the form integration of dx by x squared minus 9. So, which will take the value of 1 by 2a log of x minus a by x plus a. So when I substitute that, I'll get it to be I2 is equal to half into log of u minus 3 by u plus 3. Now I can substitute back for u as half into log of, we took u as x squared. So x squared minus 3 by x squared plus 3. So therefore the required value is, now let us combine both I1 and I2. So I'll get the answer to be I is equal to 1 by 4 log mod of x power 4 minus 9 plus half log mod of x squared minus 3 by x squared plus 3 plus c. This is the required answer. Going to the choice question B, evaluate using properties integration of minus pi to pi 3 sin x minus 2 the whole squared dx. Integration of minus pi to pi 3 sin x minus 2 the whole squared dx. First of all, let us expand it by using the formula a minus b the whole squared. So that will give you 9 sin squared x plus 4 minus 12 sin x dx. Now we know that whenever it is now going to be an odd function and whenever the limit is now going to be minus a to a, for an odd function it is now going to be 0. Now what is odd function? Odd function is nothing but when you write f of x is equal to f of minus x is equal to f of x, this is supposed to be an even function, and when f of minus x is equal to minus of f of x, then that is an odd function. Okay, so this is an odd function and this is an even function. Now look into this. Let us now separate this. Minus pi to pi 9 sin squared x plus integration of minus pi to pi 4 dx minus integration of minus pi to pi 12 sin x dx. Obviously we can see that 9 sin squared x is now going to be an even function because it is a square function, right? So even if I replace x by minus x, I'll get only plus. So it is now going to be, I'll get plus f of x only. So it is now going to be a even function, which is now I can rewrite this as integration of 0 to pi. I'll take the 9 also outside. 2 into 9 sin squared x plus, again this is now going to be, if I take, of course you can see that 12 sin x is now going to be an odd function because sine of minus 6 is minus sin x. So that is now going to, we can eliminate this. You need not bother about, because this is now going to get, you are going to get a value of 0 for that. And this is now going to be plus integration of, I can write it as 2 times into 4. This is now going to be an even function. So 0 to pi dx, simply dx. Now on integrating, I can't integrate sin squared x directly. So it is now going to be integration of 0 to pi. Now I can rewrite this as 1 minus cos 2x by 2 dx plus integration of 2 times 4 is 8, 0 to pi dx. I can now further separate this as 18 into integration of 0 to pi half dx. I can take this half also outside, and dx minus integration of 0 to pi. I'll take the half outside. That will give me cos 2x dx plus 8 integration of 0 to pi dx. So this is now going to give me, I can even take the half outside. 18 by 2 will give me 9. 9 x between the limits 0 to pi minus cos of 2x will now give me sine of 2x. So sine of 2, half sine 2 up. So sine 2x by 2 between the limits 0 to 5 plus 8x between the limits 0 to 5. So this would give me 9. Up when I substitute the upper limit, I'll get it as 9 pi. Lower limit is now going to be 0. And for the upper limit, sine of 2 pi is 0. Half sine 2 pi is 0. And sine 0 is also 0. So this whole value is now going to become 0. Plus, again, when I substitute the upper limit, I'll get it as 8 pi. So the answer is 9 pi plus 8 pi, which is equal to 17 pi. To the last question of section B. Find the coordinates of the points on the line x plus 2 by 3 is equal to y plus 1 by 2 is equal to z minus 3 by 2, which is at a distance of 5 units from the point 1, 3, 3. This is now going to be easy to solve. So, given, let us first write the line x plus 2 by 3, x plus 2 by 3 is equal to y plus 1 by 2 is equal to z minus 3 by 2. Now let us assume this to be equal to lambda, some scalar value lambda. So what will be the coordinates? I can rewrite this as x is equal to 3 lambda minus 2, y will be equal to 2 lambda minus 1 and z is equal to 2 lambda plus 3. So now he has said that it is now going to be at a distance of 5 units from the points 1, 3, 3. Now we can use the distance formula. So I can now rewrite it as 5 is equal to root over 3 lambda minus 2 minus 1 the whole square. That is x2 minus x1 the whole. Then you know the distance formula is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So I can take x2 as 3 lambda minus 2 and x1 as 1. Same way y2 minus y1 is 2 lambda minus 1 minus 3 the whole square. The whole square. And same way z minus z2 minus z1 is 2 lambda plus 3 minus 3 the whole square. So everything is within the square now. So that is now going to give you, or I'll square on both sides so that I can get rid of the square root. So 25 is equal to root over 3 lambda minus 3 the whole square plus 2 lambda minus 4 the whole square plus 2 lambda minus 3 and plus 3 is now going to get cancelled. So 2 lambda the whole square. So that, the square root symbol will go off. You don't have a square root symbol because we have squared on both sides. Or 25 is equal to, now expanding using the identity a minus b the whole square, that will give you 9 lambda squared minus 18 lambda plus 9 plus 4 lambda squared minus 16 lambda plus 16 and plus 4 lambda squared. Or when I simplify this, I'll get it as 9 plus 4 is 13, 13 plus 4 is 17. So 17 lambda squared minus 18 lambda plus 16 lambda is now going to give you minus 34 lambda, and 16 plus 9 is 25, and when I bring this 25 this side, 25 and 25 will get cancelled, so that is equal to 0. Or I can take lambda to be outside. I'll take lambda as a common factor, or 17 lambda as a common factor. I'll get it as lambda minus 2 is equal to 0. So I get the values of lambda as lambda is equal to 0 or lambda is equal to 2. Now we can take the coordinates to be, already we found out that x is equal to 3 lambda minus 2. So first case, let us go when x lambda is equal to 0. In that case, x will be equal to minus 2. Then y is equal to 2 lambda minus 1. In that case, y will be equal to, when lambda is equal to 0, this will be equal to minus 1. Same way, z will be equal to, So z is nothing but 2 lambda plus 3. 2 lambda plus 3 or z is equal to 3. So when lambda is equal to 0, the coordinates are -2, -1 and 3. And when lambda is equal to 2, same way when you substitute, you will get it to be lambda is equal to, x is equal to 3 2s are 6, 6 minus 2 is 4. And y will be equal to 6, 2 2s are 4, 4 minus 1 is 3. And z will be equal to 2 2s are 4, 4 plus 3 is 7. So when lambda is equal to 2, it is now going to be 4, 3 and 7. These are the required coordinates.